We're creating quadratic models from data, okay? So, in the first one, they've helped us out a little bit. They have 3 pictures. What we're going to do is creating a quadratic model from those pictures. And then we're actually going to take the idea of a shot in sports. We'll use something else. And we'll take information and create data from it. Okay? So, we have, this is a, what is this? An image of someone shooting a basketball. And essentially what angle is best for a ball to go into the basket. That's wonderful. Okay? But from where we are right now, we're going to say the basket, or the spot they're aiming for, is at this coordinate here. We're going to assume this goes over by 1s, okay? So this would be -1, -2. I'm just going to go, I don't really like what that does. 6, 8, 10. 2, 4, 6, 8, 10. Okay, so the spot for the basketball to land, or it looks like where all of these are converging, is at 7 and 4. Okay? Now this point isn't an x-intercept, it isn't a vertex, right? And it's not a y-intercept, so it isn't actually going to help us in terms of creating our equation for this. What we want to do is look for specific spots. Since we're going to really, I guess, focus on the shot that would go into the net, we're going to look at this coordinate right here, okay? He's shooting, and we're going to say he's on the ground. We're going to say the ground is down here. Now, normally you would call the ground the x-axis, okay? But what we're going to do is we're going to say the point of release is roughly at the x-axis. So we're going to go from there. Point of release to the ball, and we'll figure out some information from there. Because he's holding the ball a little above the x-axis, we can estimate, let's say he has to pull the ball backwards, that this would be the x-axis, or one of the x-intercepts, okay? We don't have another x-intercept, but we do have a vertex. So, of the 3 forms we know, we have a standard form, which is our y equals ax squared plus bx plus c. We have vertex, y equals a x minus h squared plus k. And we have our factored form. Factor form is y equals a x minus r x minus s. Okay. If you guys recall, we did a lesson like this last week on the blackboard. So we're going to use the vertex form for this question here. Okay? Vertex, where can we estimate this vertex to be? It's not 9. Okay, we have x value of -1. Yeah, I'd probably say about 9.5. Okay? That's where our vertex is on this quadratic. So, since we are choosing the vertex, which of the 3 forms would make the most sense to plug this information into? Obviously, vertex form. The h and the k are our x and y values. What will my h be if the x value of the vertex is -1? +1. And what will the k value be? +9.5. So, we have y is equal to a x plus 1 squared plus 9.5. Okay? Okay, so we've filled in from vertex form our h value and our k value. The last thing we need to do is actually get an a value. Now, in order to solve for an a value, I'm going to take other pieces of information. We have a y and an x. From looking at this graph, there are many y and x values I can take. We can choose to use this x-intercept that we assumed, or we can choose the basket. Because these both lie on this green line, or this green parabola here, they'll both be acceptable for estimating this equation. We'll actually take the basket. We'll take that 7 and 4 and try to work that out. Oh, sorry, -7. Thank you. -7 and 4. So, the coordinate we're taking is -7 and 4, which is an x and a y value. Our y value is 4, so we'll plug that in for y. Y now becomes the number 4. We're still looking for a. Our x value is -7, so we're going to have -7 plus 1 squared plus 9.5. There you go. Okay, so from here, the only variable left is the a variable. We substituted values in for x and y, which means we can now isolate for a to figure out what this equation will be. Okay, so we're going to go through bedmass. We still have 4 is equal to a. Negative 7 plus 1? Negative 6 squared plus 9.5. This is going to be 4 is equal to, what's negative 6 squared? Times a? Good. 36a plus 9.5. We'll take 9.5 to the other side of the equation. We'll get 4 subtract 9.5, which is equal to 36a. We bring 9.5 to the other side. Okay. 4 subtract 9.5, negative 5.5, is equal to 36a. And to isolate a, we need to divide both sides by 36.
Sorry, but why do you put the 36 with the a?
You multiply. It's the same as multiplying, that idea.
But the a is in front.
It doesn't matter. You can multiply in any order. So, the problem with this fraction I have here is I have a choice. I have a choice. I can put this as a decimal or we can put it as a fraction. Now, normally when we use fractions, we use whole numbers. What would be a way to turn this into a whole number fraction? Anyone know? Well, if I were to multiply both of these by 2, okay, we could get a fraction of whole numbers. It'll still be a negative fraction, which makes sense. Our a value should be negative because it's a parabola facing downwards. 5.5 times 2.
Negative 11.
Okay.
Over negative
72. Okay. So here's our a value, which means our quadratic was y is equal to negative 11 over 72.
Can you break that down?
X plus 1 squared plus 9.5. Okay? We don't need to. This is an acceptable equation for our parabola at the top here, the one we've done in green.